Yeah. All right. We're up and running. It's 8:35, so we'll get started. This is COMP2404, Introduction to Software Engineering. I'm Daryl Hill, your instructor. So we are here on September 23rd with the Friday morning crew. One of these days I'll bring in some coffee as a reward for your diligence. We're actually still on constructors and destructors, but it's fine because I'm sort of restructuring things a little bit on the fly because I wanted to give you guys as many tools as possible to complete assignment 1 as early as possible. So it's the beginning of this course is a bit of a work in progress. I don't quite have things the way I want to, but it's getting there. And so today we're actually going to do something a little bit different as well. We're going to continue talking about constructors and destructors, but I'm going to give you a little bit of memory management because the one tool, I guess, that I haven't given you yet for assignment 1 is double pointers. So we're going to do a little bit of an example of double pointers, which is technically from memory management, but yeah, I do want you to have all the tools possible as soon as possible. And then we'll get into details a little bit later. Okay, so tutorial 2 is due tomorrow, and tutorial 3 I'll release just later today. Tutorial 3 is simply, it really is just classes from your assignment. And it runs some tests on them. It's some of the marks from your tutorial are duplicated on your assignment, but it's really meant to be incentive to start early, essentially. So in the future, a lot of your tutorials will be related to your assignment so that, you know, it helps you to begin things early, but yeah. Any questions on the calendar or anything else before we get started? Okay. All right, so last class we had started on constructors and destructors. In particular, we had talked about default arguments. So we looked at a function. Let's see if no, it's the wrong one. We looked at a function here, do the math, where we put default arguments. So we put a default operation for the last element here. Seem to have the sniffles. This is I don't have any Kleenex. It's just all right. I'm gonna sacrifice my thing here. Sorry, excuse me. I have a bit of allergies or something this morning. I don't think I'm really sick, but I just have the sniffles. I don't know. If it gets worse, we'll see. Okay. And then, so we were going to extend default arguments to default constructors in a class. So we will do that, and then we will do a little bit extra on that. So default arguments can be used in global functions, member functions, or constructors, all right? Although we do have to be careful of the function signatures, because in C++ we can do what's called function overloading, which means that we have two functions that have the same name, but maybe different arguments, which is fine. C++ is okay with that because you have a unique function signature as long as, you know, something is different from one to the other, either the name or the parameters. However, if I supply default arguments, then now this has more than one function signature. So I can call it, if I call fun1, I can say pass in a number, or I can call fun1 and pass in nothing. So now I have two function signatures. Both of these apply to this one, and the no argument signature applies to that one as well. So if I call it with no arguments, the compiler is not going to know which of these functions to run. So we have to be careful of that. When we start using default arguments, we are increasing the number of function signatures for that function. Okay. So this is all going to bring us to, I mean, you can use that in any function you want, but in particular, we're going to be looking at constructors. But every class is provided with 4 member functions. So we have a default constructor, a default destructor, a default copy constructor, and an assignment operator. You get these things for free as long as you don't make them yourself. So if I don't make a constructor, a destructor, a copy constructor, or an assignment operator, which you can do, we've only seen constructors so far, then you get these for free. And so the compiler has some default things that it does, which are very, very simple and straightforward. However, if we override these, particularly if our class contains dynamic memory. So default constructor is, we often write new constructors. That's not a problem. But if we have to write a destructor or a copy constructor or an assignment operator, then likely we need all 3. And this is known as the rule of 3 in C++. And we're going to see why when we get onto memory management, but basically it's because we have dynamic memory. And if we have dynamic memory, we have to handle it, make sure it's handled properly. Dynamic memory is, of course, memory that's allocated on the heap. So something I called new somewhere in my class. There's also what's known as the rule of 5. If you get into more modern versions of C++, we're not going to worry too much about that. We might look at it a bit later, but modern compilers also include what are called move constructors and move assignment operators. We're not going to, well, we cover them briefly, but essentially, I'll talk about them a little more when we get to copy constructors and things. It'll make more sense then. And then there's the rule of 2 if you watch Star Wars, Anyway. So a default constructor can be a 0 argument constructor. So we've seen in our, what did we see it in, date or student? I think date. We've seen a no argument constructor that looks like this, or a constructor with all default arguments. Well, we haven't seen that yet, but here it is. So if we wanted to have our class date to have a default constructor that had default arguments, we could supply them simply by assigning them in the function prototype. So constructor is a function, so yeah, and it has a prototype, so we will assign it those values in there. The same as do the math. We didn't put the default arguments in the implementation, but just in the prototype. Again, we run into the same problem here that we showed earlier with fun1, is that this constructor and this constructor now have the same function signature, right? So I can make a new date with no arguments, but if I include both of these, then the constructor won't know which one it should be calling. So yeah, if we make all default arguments, we don't need this guy. All right, so that is to say you're allowed 1 default constructor per class. If you don't provide any constructor at all, a default constructor is provided for you. If we provide any constructor, we no longer get a default constructor for free, but we can still make one. So constructors in general have one purpose, that's to initialize all data members. So our classes, we've seen a student class that had name, student number, GPA, etc. We saw a date class, I think. We see a date class yet? I think so. That had day, month, and year. In your constructor, you should initialize all those. Again, one of the pitfalls of C++ is not initializing variables. Now you get whatever is left in that memory location. Sometimes it's 0, which is, probably what you would expect in a lot of cases. And then so your code's going to work sometimes, but then at some point in the future, you'll get a weird error where you have this corrupt data. So always initialize your data members. in every constructor. All right, so let's take a look at programming example P2, and we will, do a little bit on the fly as well. Okay, so here we have our date class, date.h. And we have two constructors here. We have a default constructor and a 3-argument constructor, and everything else is the same as it was before. So if we look at our code now. Oh yeah, that's right. I was going to. Change things up a little bit this morning. Yeah, okay. So what we're going to do now is get rid of this default constructor and make our regular constructor into also a default constructor. So we'll say 1901 was our default year. The default month was 1 and the default day was 1. All right, and it's complaining because I started on the left and I moved to the right, but once I have them all there, now it's fine. So instead of having 2 separate constructors, now I have one constructor that acts as a default constructor. Of course, I still have this, which the compiler does not like. And yeah, here's my constructor. I don't put any default arguments here, the same as before, because this is the implementation. So yeah, technically now I have a default constructor, and let's take it for a test spin. So I could say date D1 2022. What is it? 9. Today is the 23rd. And then I'll say D1.print. And then I will do an end line here for a little bit of formatting. And then I'll make a second date D2 with no arguments, D2.print, and a little bit of formatting. No targets, no makefile. Do I not have a makefile here? Oh no, I have to go to P2. Okay, so there. I have my default constructor works the same as before, except now I've implemented it using default arguments. The other nice thing about this, it has these 2 function signatures, but it also has more than that. I have D3. I can, for instance, say 2022, October, and then I'll just say, well, I'll let it fill in the last detail itself. So I'll just use the default today. I'll supply arguments for the year and the month. And then print that. And I can also say, well, I'm only going to supply the year. And then I can use the default month and day. Okay, so yeah, October 1st, 2022 and January 1st, 2022. So yeah, simple enough. Any questions? Okay, so let's do something a little bit different now. I'm going to do an example using double pointers just to give you guys the syntax. So what I'm going to do is, and I haven't actually done this, so I mean, it's possible that I make a mistake somewhere, which is kind of fun. But let's say I want calendar.h. So I'm going to make a class called calendar. And then I'm going to make a second calendar.cc. Oops. That's not what I wanted. Okay, so I'm going to make a calendar composed of my dates. So in my .h, of course, I want let's see, class calendar. And then I need a semicolon. And now I'm going to have in my class, my calendar class, I'm going to have an array of dates, 365 of them. So let's make them pointers. So I'm going to have every day of the year represented, and yeah, and then I'm going to use double pointers to retrieve them. Of course, the compiler does not know what a date is, so I'm going to tell it. So I include the date.h, which now the compiler has all the information it needs. Yes, perfect. Okay. I also want to define my own constructor here. I don't need any arguments, well, maybe the year, but we'll use 2022. It's going to be a very simple class. And then what we're going to have here, this should be public. Is just a getter. So void get date, and then I'm going to supply an integer, which is a number between 1 and 365, and I'm going to return the date that's associated with that number. And how am I going to return it? Using an output parameter, in this case, a double pointer. And we'll see why that's useful. Because I don't want to return by value, I want to return the actual object from this array. So to do that, I'm returning a pointer, so I need to pass in a pointer by reference, which is why I have a double pointer here. Again, we're going to go into more detail in that next week, but for now, I want to give you the syntax so that you can use it on your assignment 1. Okay, so I have my very simple calendar class. All right, now I'll have the .cc, the implementation. I want to, of course, include the header file. And then I have calendar. I want to write the constructor. I have to scope it in using the scope resolution operator. Okay, so this tells the compiler that this is the constructor for my calendar class. And in here, I want to access my date, but I want to, so I want to make my array, I want to fill my array full of dates. There's one other thing I want to do. I want to be able to take a date and then have a function that gives me the next day. So what I'm going to do is I'm going to make a small change to my date class. I'm going to add void inc date that takes a date reference. So this is going to take a date and add one date to it. And it should be fairly simple to implement. Let's see if I manage to do all this. So in my date.cc, I'm going to add an implementation for that, inc date. Okay, so let's see, I have a setter that takes a date object. So I'm going to start by just setting the date to the previous date. And then I'm going to change it. So I'm going to say day equals or plus equals 1. Okay, so I'm going to increase the day by 1, and then I'm going to check to make sure that it's not greater than the max day. So if day is greater than, what did I call it? Get max day. Yeah. So if I've gone, if my date is now past the end of the month, I'm going to increment my month and set day to 1. So day equals 1 and month plus equals 1. Okay. I could continue to do this. I should now at this point check to see if month has gone over, but I'm not going to. This is going to be sufficient for our purposes. and if month has gone over, actually, whatever, we'll make it complete. If month is greater than 12, month equals 1, and year, I'm going to add 1 year. Okay, so now I have this increment date function that takes a date and gives me, I supply a date as an argument, and it gives me the next day in the calendar year. Okay, questions? Okay. So now going back to my calendar, I'm going to write this constructor dates 0 equals new date. And I'm just going to supply the year because it's going to give me the first day of that year. Okay, so that's fine. Now I want to find the rest of the days. So I'm going to loop int I equals 1. I'm going to start at 1 instead of 0, which I normally would. I is less than 365. I'll have to. Okay. Yeah, so now dates I equals new date. And let's supply the, no, that's fine. So I'll just have the default date, and then I'm going to set it to the previous date. So I'll say dates I inc date, and as an argument, I'm going to give the previous date dates I minus 1. All right, and I dereference it because it's a pointer, so I'm going to pass in the object. Now I should have, in my calendar, I should have all of the days of the year properly represented, year, month, and day, hopefully. And then here I have a get date. Get date. I take an index and a date double pointer. Void, yes. I need a return type. Okay. So what I want to do is I want to say if index less than 0 or greater than 365, I will say, so now, since it's a double pointer, if I want to get to the pointer, I have to dereference it. So if I dereference it once, I get to the pointer. If I dereference it twice, I get to the object. But if this happens, I want to set the pointer to null and return. So this is, you sent me a bad index, so I'm just going to, I'm going to set it to null so that you can do a null check and make sure that index. And make sure that you have something there before you start trying to call functions on it. Okay, so now I know I have a good index. So what I'm going to do is I want to return the pointer from this class via my output parameter, D. So what I want to do is I want to set that pointer to dates at the proper index. Okay, so I dereference it once, that gives me the pointer, and I assign that pointer, the pointer that's in my calendar. Okay, so we're going to go over this in greater detail later, but what I've essentially done up here is I passed in a pointer by reference using a double pointer. C++, you can actually go up to, I think, 12 deep on pointers, so you could declare something like and so on up to, I think the standard is 12. It has to be at least 12, which is, I don't know what you would ever use that for, but yeah. So again, we're going to get into more detail a little bit later, but this is just some syntax you can use. I'll post this with the code for the class. We're not quite done. We still have to go to the main and call it, but any questions? Yeah.
For the constructor, right? Since we have a statically allocated array of like pointers, do you have to like initialize it in the constructor? Or you just leave it as it is?
Yeah, so far we've only seen statically allocated arrays. So the array gets allocated along with the, in this case, the calendar. So wherever I store the calendar, there's this big array of 365 date pointers. So that's the reason why we use, I mean, that's actually bad, right? Because you don't want to store huge data structures along with your object. You want to store all those things on the heap, because otherwise you can fill up your stack if you allocate a calendar on the stack. Your heap is a lot more flexible. But yeah, any other questions? Okay, so we'll see it in use, and then hopefully this all works. So let's go to my main function. I'm going to, yeah, sure. We'll keep these for now. We'll make a calendar. All right, so the compiler does not know what a calendar is, so I will tell it. Oops. .h. Now I've included calendar.h, and you can see the value of these header guards, which I didn't put here, but my class date has header guards. So what I've done is I've included date.h in my calendar class. So the compiler starts reading. Well, let's follow along here. The compiler starts reading here. It sees the date.h, goes into date.h, reads this. So now it knows about the date class. In the next line, it goes to calendar.h. It starts reading calendar.h. It says, go back to date.h and read that again. So this is a problem. If it reads that twice, it's going to say, well, you defined date twice. So why did you do that? That's an error. I'm not going to compile that. So that's what the header guards stop. So it read it once. When it read it, it defined this preprocessor constant. The second time it goes to read it, it says, is this defined already? Oh, it is. So I'll just skip all this. I already know what a date is. So that's what the header, the preprocessor, or sorry, the header guards do, is they stop these multiple definitions, right? All right, questions? Okie dokie. Let's see if this works. So I have to update my make file and include a calendar. Again, all of your classes are going to look the same. So I can just sort of take my date. All of your classes should be compiled to object files and all have this exact format. So I have now my calendar.o, and I want to link that up here. Okay. So I've updated my make file. Now I should be able to, well, at this point, let's just see if we get an error at this point. It's a good idea to not write too much code before trying it out. So far, so good. Okay, no errors. I have a memory leak, but that's all right. I'm okay with that right now. So good. Let's try our calendar then. Let's say, so what I want to do now is I want to get a date pointer from my calendar class. So I'm going to declare a date pointer that I can pass in. So date, yeah, but it's a pointer. I don't declare a double pointer. If you declare a double pointer, the compiler is going to get confused. We will address that in the next lectures. For now, I just want to get the syntax down. Only declare a pointer. I'm passing in a pointer by reference. So I want to pass in the address of the pointer. So I'm going to say cal.getDate let's see what the 100th day of the year is. And now I want to pass in the address of my date pointer. So when you think of a double pointer, you can think of, when you think of a pointer, you should think of, well, the pointer is an address of a date. A double pointer is the address of a date. So I'm passing in the address of a date, so that when I dereference it, I get back the original pointer and I can actually make changes to that pointer, right? So I want to return the memory address of this date and put it in this pointer. And then, well, let's see. The moment of truth is date print. We'll see what the 100th day is, if I made any mistakes or what have you. So the 100th day of the year is April 11th, 2022, which is, thrilling. Let's see if we get, let's do a couple sanity tests. Let's try 365. Segmentation fault. All right, so there's an error. Let's try 364. December 31st. Aha. Yeah, so my get date is not, it takes a value from 0 to 364. There's 365 days, so I should, if I wanted it to get the 365th date, if I wanted to call it by using a number between 1 and 365, I'd have to add 1 or subtract 1 from that value inside the getter. As it stands, though, it does work. But yeah, my bounds checking is not quite right. All right, so the main takeaway from this is two things. How to declare a double pointer, a getter with a double pointer, how to use it, right? I dereference it to get back the pointer, and then I can assign that pointer. This pointer is going to be returned, right? So I think there's a get truck function in your assignment 1. You should use exactly this syntax. Now, when I want to use it, I declare, actually, I think that part is done for you in the test functions, but if I wanted to use it, I don't declare a double pointer and pass it in. I declare a pointer and pass in the address. And yeah, and then once I've done that, it's going to, I should maybe do a null check here to make sure that I got a segmentation fault because I didn't do that null check. But yeah, and then I can use it as I would any other pointer, but it's actually pointing to the same object that I made in my calendar class. All right, questions? Okay, I'll put that up on Brightspace. Feel free to use it, copy it, make sure you do the, because double pointers are tricky and we're going to learn more about them next week, but for now, I just want you to be able to use it. Okay. That's, yeah, default constructors and double pointers. Okay, so default constructors are called implicitly when an object is declared with no parameters or an array of objects is declared, right? So when I declare an array like this, the constructor is called on each one of those elements. I could have in my calendar class done an array of date objects, and then I wouldn't have had to call new each time, but that's fine. The default constructor is also called when we dynamically allocate memory using the new operator, like this, with no arguments. So these are 3 common ways that our default constructors are called. So yeah, destructors, so memory cleanup. Maybe we'll go back and clean up our memory and calendar in a minute, but so a destructor is like a constructor. It's a member function of the class. So it's just a function. It's called just the same as a function. We get one for free. If we don't write one, we get a default destructor. And this is called at the end of a life cycle of an object. So we can cause it to be called. We never call it directly, but we can cause it to be called depending on what we do. So each class gets one destructor. So we can have multiple constructors, but we only have one destructor, either the default or we write one. In any case, it has no arguments, right? It needs no information. All it wants to do is deallocate my member variables. That's it. Or, if it's a file, it might close the file or something like that. So if I call delete on dynamic memory, I immediately trigger the destructor. So it gets called right away. So yeah. For statically allocated memory, it's called implicitly at the end of the object life cycle. So this is when, if a local object goes out of scope, if its containing class gets deleted, etc. So the default constructor, we have a function signature that looks like this. The destructor is the same thing, but we have a little tilde at the beginning. The only difference. Okay, so how do we use it? We use it to perform cleanup, release resources. Release memory is the most common one that we're going to use, but also we can close files. We can save state if it's a game and somebody shuts it down. Well, I call the destructor and maybe the destructor saves all the game state so that whenever they reopen the user reopens the game, they can pick up where they left off. So it's for stuff like that. We will mainly use it to release dynamically allocated memory. In other words, all of the things, if we had everything that we called new on in the constructor, we should probably call delete in the destructor. And yeah, we have to write the destructor code. If there's dynamic memory, the compiler has no way to know what resources we want released, if we want to close a file or delete dynamic memory or what. So destructors are called when locally declared objects move out of scope. If I have global objects, global variables, then those are called at the end of the program. Or when I call delete on something that's on the heap. So those are basically the three conditions for the destructors to be called. If I have multiple objects, destructors are usually called in the reverse order of the constructors, but not always. So yeah, let's take a look at an example. Okay, so I have here P3. Let's close some of this stuff up. Awfully cluttered here. Okay, so P3, I have a class called thing, right? So this is it's a simple class that we're just going to use to identify when things are constructed and when they're destroyed. So I have my header guards, I have my class declaration, I have a constructor with default arguments. It takes an integer that's an ID and a string that's a location. So yeah, all we're going to do is in the constructor, we're going to assign these to the member variables, and then we're going to print out to the console basically the ID and where this was constructed, right? So we're just gonna, basically this could be a print function, but we only need the constructor and the destructor. In the destructor, we're going to say that we're in the destructor and which thing is being destroyed. So we can take a look and see what gets destroyed when. Okay, so all right, so we have a main function here. We've included our thing.h so we can make new things. So we're going to say we're in the main function, and then this is basically the sign that we're going to exit. It's a line from the cat in the hat because we have a bunch of thing 1 and thing 2 and thing 3. But yeah, so that's the beginning, that's the end. It's make sure everything works so far. Okay, so we begin main and then we exit main. And yeah, it's always a good idea to test often, right? Don't write a bunch of code. Don't write pages and pages of code and then start testing at the end. Write a little bit and then see if that works, and then write a little more and then see if that works. Debugging hundreds of lines of C++ is not fun. So you want to, if you know something works and then you've added a function and then it breaks, then you know the problem's in the function, probably. Okay, so what we're going to do is we're going to declare some global things. Thing 1, we're going to say this is 1, and global thing. Okay, and then we'll make another one here, thing 2, also a global thing. Okay, so let's see what happens with these guys. Okay, so before we even enter main, these two things are constructed, right, in the order that we declared them. And then once we exit main, we can see the destructor is called on both of them, but in the reverse order of the constructors. So thing 2 is destroyed first, and then thing 1. All right, so there's nothing, since these are statically allocated, we cannot call the destructor, we cannot call delete on these things. They get deleted at the end of the program, no matter what happens. All right, that's good. Let's make a couple more things. So in my main, I'm going to declare, I could actually declare thing 1 and thing 2, but I'm going to thing 3 and thing 4. Oops. And this is main function. Okay. Again, these are statically allocated, so here, let's declutter a little bit, run that. So our global things are made, then we enter main. Now our local things are made, so thing 3 and thing 4. Once I exit the main function, then my locally declared variables are destroyed, and then I exit the program, and now these things are global things are destroyed. Again, these were destroyed in the reverse order that they were made, right? So this is when the destructors are called implicitly, that's generally speaking what happens. All right. Questions so far? Simple stuff, eh? This comes into play especially when we get into inheritance and when objects contain other objects, because it affects, how you write destructors and things. But let's make a thing. What are we at? Thing 4, thing 5. Let's say 5. This is in main dynamic thing. Okay. Okay, so my thing 5 in main dynamic thing gets made third. So basically, which we would expect. It's these things are created as the code is run. You notice that the destructor was never called, even when we exited the program. The memory gets released at the end of your program. Once your program ends, all the memory is released, but we've never called the destructor on this class. So yeah, let's say we go here. Actually, let's do it. And then let's delete thing 5. Okay, so we made thing 5, and then we called this line before destruction, and then we called delete. And as soon as we called delete, the destructor was called on thing 5. So dynamic memory, we control when that destructor is called by this delete. So this deallocates it and calls the destructor on our object. And yeah, everything else is still in the same order. Now we've cleaned up all of our memory. Everything is great. All right. We also have a function called func. We're going to put a couple more things in there. We got 6, 7. It's a func thing. Okay, so cout func. Exiting func. Okay. And then so in here we can call func. Let's call it right here. Okay, so we call before destruction, we write that out, then we call func before we delete thing 5. So before destruction is here, and then we declare that we're in the function. Thing 6 and 7 get made. We exit the function. Thing 7 and 6 get destroyed. All right, so they go on the function call stack. When we return from that function call stack, the destructors are called for us. Okay, and then after that, we of course delete thing 5, and then everything else works as expected. Questions? I promise you this is useful at some point. I can declare another, where are we at? Last one. We'll say global thing. So now I've declared a third global thing after my main function and before my func function. However, any global thing gets, the constructor is called, it gets made regardless of where it appears in the code. So generally speaking, the compiler is pretty primitive. It just starts reading at the top and keeps reading, but that does not apply to these global variables. Here it says, well, that's fine. I see that it will instantiate this before it runs the main function. And then it gets destroyed, of course, at the end here. The first global thing to get destroyed. All right, so that's about it for that. Questions? Alrighty. Oh yeah, let's see. One last thing. Let's say that I call exit with an error code of 1. Doesn't matter if I give the error code or not, but I'm going to call exit before I exit the main function. So we have a lot of things now, so hopefully it's still clear what's happening, but before destruction, and then we exit, we'll notice that the local variables did not get destroyed. So the local variables in the main function, the destructors were not called. The global variables, we still have the destructors called. So if we call exit, local variables won't have their resources wrapped up, but the global ones will. If we call abort is for something a little more catastrophic. So before destruction, aborted, no destructors are called. By abort, it's just game over. Something really bad happened, and I don't want to close resources because I don't want to save this corrupt state. I just exit everything. All right. So yes, exit is, if you run into a problem, your program terminates immediately. Global variables are still cleaned up. Local variables are not. If something goes really wrong, call abort, and then none of your destructors are called. Sometimes that's what you want. Okay, so copy constructors. So these get called a lot in C++ as well. We get one for free. It's a member function of the class. If we don't make one is given to us, and we'll describe what it does. A copy constructor takes a single argument only, which is a reference to an object of the same class. So here we have the function signature of a date copy constructor, or you can say, you can pass in a constant date. So we'll get into what that means. Const means constant. It means we can't make changes to this date variable. We're going to cover that a little bit later. Anything other than these two things, the compiler will not recognize your copy constructor. You cannot add in extra variables. The compiler won't like that. And it will not take an object, and it will not take a pointer. It has to be a reference. We can call them explicitly by passing in. If I'm constructing a date object, I can pass in another date as an argument. Or there's a lot of ways that it gets called implicitly. C++ likes making copies of things. It's one way to keep things safe. I mean, if you just made copies of everything, then you make sure you're not corrupting the original. But so by default, that's what it does. It's just inefficient. So a copy constructor is provided by default. It performs what's called a member-wise assignment. Okay, so I'll explain what that is. But what that means, well, yeah. So if we have a pointer to the dynamic memory, it does not make a copy of that, right? So let's say I have a student, and inside my student is a date pointer. I don't know if you guys can see that all right. So I have a date pointer, and I make a new date in my constructor, and that points to the heap, right? So the new date is made on the heap. So this, once I assign it a new date, allocates this and points it on the heap. Now, if I make a copy of this student using the default copy constructor, I get a second student. That also has a date pointer. Probably can't see it all now, can you? Yeah, you guys can't see that. All right. Well, it's pointing to the same thing now. So if I make a copy, I still only have one date in memory. So that's what's called a shallow copy. We're going to go over that in a little bit more detail, but that, of course, hopefully you can see why that might be a problem. So now if I just wanted to have a second student, maybe a student is a bad example, but maybe I wanted to have a second object that was a copy of the first. But if I make changes now, those changes are reflected in both objects, which is probably not what you want. So yeah, that's shallow copy as opposed to deep copy. We're going to talk about those in more detail. There's also something called a conversion constructor. It has a similar job, but it takes a reference to an object of a different class, something related. We want to make a copy of something, but convert it to something else. Okay, so the usage of copy constructors, we want to make a copy of an existing object. So what we're doing is initializing the values with values of another object. Of course, in C++, we can access the private members, right? So I can, even if there's no getter for this, I can still make a copy of it in my student class. So how we get the copy constructor called, Well, there's a few ways. So this is just a plain declaration of a student object that calls the default constructor. If I declare and assign my student object in one step, then the copy constructor is called. Right, so in this case, Bertha will be copied into Matilda. If I declare Matilda first and then call the assignment operator, it's still going to make a copy of Bertha, but it's not going to use the copy constructor. It's going to use the assignment operator. So yeah, these are important distinctions that we're going to look at a lot closer in a minute. When I declare a new object, I can pass in an existing object of the same type. That will call the copy constructor. Or if I pass, so we talked about how we always pass objects by reference or pointer. You can pass them by value, and there's probably use cases for that as well. But so when you do that, the copy constructor is called. So it's going to make a copy of your object in this new object. Okay, let's see. Okay, so I have a song class in this example. Okay. And it's, pretty simple. I have an ID, I have a title and an artist that are both strings. I have a print function, so it doesn't really do anything too special. And then I have my 3-argument constructor that initializes this song. And then, yeah, so this is, and then it writes to the screen that, oh, the regular constructor was called. Okay, so that's, yeah, and then when I print out the title and artist. So what I want to do is add a copy constructor to that. So in my main, I make 4 songs. I print them out, and then let's just do that for now. Okay, so I make 4 songs, I print them out. So yes, I called the default constructor in each case, and then I have a bunch of songs here that are printed out. Okay. Now I want to make sure that there's a copy constructor and see all the ways that it gets called. So the copy constructor, we know the, yeah, let's also make a destructor. We'll do that later if we have to. So the song copy constructor simply has this signature. So it just takes a reference to a song object, and that's it. So that's the declaration. There is a default one, but we're going to write our own, and our own is going to do basically the same thing a default copy constructor does. Okay, so what we're going to do is we want to take all of the elements from our original song and copy them into this song. So, well, that's simple enough. ID equals song dot ID. Even though these are private, I have access to them because this is the same class as the current class. So artist equals song dot artist. And was title. And then let's just announce in the copy constructor with the ID. Yeah, ID is, that's all we need, eh? And okay. Yeah, so this is what's called a member-wise assignment. And what I've done is I just looked at every single member variable in my song class. So I have 3 of them, and I just copy them directly. Boom, 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 assignment operators. If I had a pointer in there, I would simply copy the pointer address. That's what this, or well, that's what the default copy constructor does. It does exactly this. Looks at every single member variable and just makes a copy of it in your new class. Okay, so this is basically what the default copy constructor does, except we're actually printing out, let's put the artist in. A little more information here. Okay. And then let's make sure it gets called. So we've made 4 songs. Let's. Okay. Let's make a 5th song here. Okay. So we're declaring song 5. We're using the default constructor. We're going to print it out. And then we're simply going to assign song 4 to song 5. This does not call the copy constructor, as we will see. Okay, so we declare song 5. We have a default with an ID of 0. And then we assign song 4 to song 5. So now when we print it out, song 5, we have the same as song 4, which is, Motley Crue. Okay, so that's the assignment operator. And now we're going to declare and initialize in the same step. So here, we're going to make a copy of song 5. We're going to declare song 6 and assign song 5 to it right away. Okay, so declaring and initializing song 6 from song 5. Now we can see it says we're in the copy constructor of 4 with the artist Motley Crue, and then we print it out. So in this case, in the original case, we declare song 5 and then assign it. That does not call the copy constructor. It calls the assignment operator. Here we declare it and we assign it in the same step, and that does call the copy constructor. Yeah. Questions so far? All right. It's Friday. You guys made it through a second week. You should be proud of yourselves. Okay. Let's do another example. Here we will declare our song and pass in an argument explicitly. So here we're explicitly calling our copy constructor using the copy constructor signature. Here it was implicit. The compiler handled the conversion, but here we're doing it explicitly. So yeah, let's see. Explicit call to copy constructor. Again, it says that we're in the copy constructor with the Motley Crue song, and we've made a copy. We're printing out song 7, and it's still the same song. Okay. Let's look at another example. So we've declared 3 functions up here. So I have a pass by value function, a pass by reference function, and a return by value function. This one might be the most interesting because I think the compiler actually optimizes it for us and does some tricky stuff in the background. So here, let's get rid of all this first of all. Calling return by value. Let's start with, so of course, pass by reference. I'm passing in song 1, pass by reference. That, of course, should not call the copy constructor because I'm passing in the address of this song. So yeah, calling pass by reference. All it does in pass by reference is, I think it just prints the song. Let's see. Yeah. So in each of these, it just prints the song and then exits. Return by value makes a whole new song, but we'll get to that in a second. So let's call then pass by value. So here in my pass by value function, I'm passing a song, not by reference, not by pointer. So what's going to happen is a copy is going to be made. So calling pass by value in the copy constructor. So it was song 1, so there was Nirvana. So it made a copy of that song and passed it into the pass by value parameter, and then printed it out. And then, yeah, I guess it wouldn't hurt to have a destructor, eh? Sorry, I'm going to put a destructor here so we can see when the destructor is called as well. Yeah. Song destructor. Okay, well, let's print out the artist as well. Okay. Okay, so I called pass by value. I made a copy of this song. I printed it. When we exited, that copy got destroyed. And then the original, which was a local variable, got destroyed when we exited main. Okay. So yes, that's why and if all we did was print it, then passing by value doesn't make a lot of sense because we're making a copy for nothing, and it might be a huge object. So the final one that we want to look at is return by value. So in the return by value function, I declare a local variable, a song, and then I return it. So it's going to get here, I think the compiler does some fancy stuff for us. So it used to be that this would actually, it would make a copy in here. So it would make this local variable. So you'd see the constructor called, and then it would make another copy when we returned it. But I think the constructor, well, let's see what happens. So where is return by value is here. Yeah, all right. Well, it might make sense. Okay, return by value. We called the default constructor and then the destructor. However, we called it and it should have returned it, but we didn't assign it to anything. So of course, if we assign this to something, what do we need? S5 equals return by value, then this should call a copy constructor. We'll see. Okay, calling return by value. Yeah, see, that does the s5.print. Yeah, so calling return by value, it called the constructor, we returned it and it printed. The copy constructor never got called, so that the compiler is in the background. It recognizes that this local object gets returned, so there's a little bit of compiler optimization going on. It used to be this would call the copy constructor, but what happens is the compiler says, well, I'll just make room in the previous stack frame for it since I'm returning it anyway. But yeah, it's a little bit advanced. You don't have to worry too much about that. I don't think we do return by value at all. But yeah, questions? 10 minutes left, huh? Okay. Finally, a conversion constructor. It's similar to a copy constructor. It's a member function of a class, but it takes a parameter of a different data type. right? Basically, we use it often if we want to make a copy of something that's very, very similar to something we have. So for instance, if we have a date and then we have we wanted to make a date time object. So we could have used this actually in our reservation class for the assignment, but we didn't. So yeah, if I want to make a date time, of course, in my date time, I would have a date implicitly. And maybe instead of having a date member variable, I want to have a whole new object so I can handle my day, month, and year any way I like. So I can make a conversion constructor. So conversion constructor will be called on initialization if I try to initialize my date time with a date object, or if I use pass by value or return by value. I think return by value works in this case. So yeah, to use it, yeah, ideally these should be logically related types, right? I don't want to convert a date into a student. That makes no sense. Although I guess whatever, maybe there's an application where that's relevant, but it should be something similar, something where the information you need in this object is actually relevant. So yeah, conversion constructors like copy constructors can get called implicitly by doing pass by value or return by value, but we can disable that by using the explicit keyword. So we can make a conversion constructor and then tell the user, listen, I only want you to use this if you know what you're doing. So I don't want this to get used by accident. So you can still explicitly call it by passing in that member as a, when I declare a new object, I pass in the other object as a argument to the constructor, but all the implicit uses are disabled. So let's take a look at that, and then we're done for the day, or I'm done for the day. I don't know about you guys. Okay. So again, we have our song class. It's the same as before, roughly. We have some getters here. I think we need them at some point. I forget why I put them in there, but I'm sure we'll find out in a second. And then we have the implementation, the same as before. We're basically declaring we're in the default constructor, copy constructor, etc., destructor. So maybe though, oh yeah, there's my main. So I also have a video. So I don't know, once upon a time, it was very popular back when I was younger. I guess they still make videos for songs, I'm sure, but it used to be a big, big deal. But when I make a song, maybe I want to make a video of the same song. All right, so I have a class called video that takes a couple strings, a title and an artist and a length, and we'll assume everything else happens. There's some, director or whatever. All of that is handled, and we're just passed in this. We're going to be passed in a song, and we're going to make a video to accompany that song. All right, so we have here a conversion constructor. So I have, I declare a constructor in my video class, and I pass in a reference to a song object. Yeah, other than that, quite simple. So I make 4 songs again. But let's see, I have different similar functions, but a little bit different. So I have a video pass by value function. So I pass in a video by value, and I have a return by value function. So what I'm going to do is, again, let's not get too carried away here. I'm going to comment some of these out. Let's start with, and try return by value to start. So return by value returns a video. So what it does is it makes a song and then returns that song when it should be returning a video. So let's see what happens here. To be honest, I don't even remember what's going to happen. Okay, so the song default constructor gets called, the video conversion constructor gets called, and then it returns this video object that gets destroyed because I didn't assign it to anything. So yes, in the case of a conversion constructor, the compiler, of course, can't do that fancy, the compiler has to call some constructor. It can't do the fancy thing where it makes a song in the function and then just allocates that in the previous function. So yes, return by value. If I return a song by value, the conversion constructor is called implicitly. All right. So here I can, in this case, I'm simply making a video without calling the conversion constructor. So that probably would have been the logical place to start. But just as a proof of concept, yeah, I can make a video without passing in a song as a reference, or I can make a video of song 2, which is, yes, the Dirty Nil. If you haven't seen them, they're fantastic. So yeah, creating video 2 from song 2, again, the video conversion constructor is called. So I turn this song into a video. All right. The other use case is, again, I declare it and assign it a song all in one step. This is, you know, this would call the copy constructor if these were the same type. But in this case, creating video 3 from song 3, the conversion constructor gets called. So I can do this. I can't do, I think this will not, you would have to write a assignment operators to do this. This is, I'm surprised it's not giving me an error here. Let me see. Yeah, it did actually. Yeah, called a conversion constructor. Interesting. All right. Well, I learned something today. I didn't expect that, but yeah, apparently just using an assignment operator will implicitly call the conversion constructor. And then, of course, pass by value. Oh, that's weird. Okay, so video argument passed by value. Again, the conversion constructor is called. All right, questions? We have 2 minutes. There's only one last thing I want to show you. Not here, where is it? If I wanted to disable all of these implicit calls, I just add the explicit keyword. So this is a conversion constructor, and now I'm saying, now you can see my things lighting up like a Christmas tree because I have 3 errors. So all of the implicit calls to the conversion constructor are now disabled. So this one, these are all implicit calls, but my explicit call to the conversion constructor still works. Let's do this one also. Yeah, that one is also a problem. So if I say explicit, then what I'm telling the user is that this is the only way you can call this conversion constructor, is if you really, really want to call that conversion constructor. I don't want it getting called accidentally by passing it in by value somewhere or returning by value. All right, questions? No? All right, have a good weekend. Get your tutorial 2 in, and I'll release tutorial 3 today, and I'll see you guys next week.